I'm from Chennai, and I'm absolutely happy to see so many Chennai Super Kings here. So excited to be here. My name is Ramesh Mahalingam, and I'm the founder and CEO of a startup called Vizru. And Vizru was founded about 3.5 years ago. And I'm absolutely excited to share our experiences. And we have been growing about 100% year over year for the past 3 years. And we have just opened or launched a center in Europe, and we're opening one in Singapore in the next few months. So I'm absolutely excited. Thank you.
Well, thanks all of you. Like I said, the resume is impressive just to be around these guys. So, yeah. Clicker. All right. So mostly I'm just going to be talking about 5G. Mostly I'm going to be talking about 5G, and let's start with where we are in the wireless industry, right? This is, again, the good thing I did is that I plagiarized every single slide, but I acknowledge where I plagiarized it from. It's all from CTIA, which is a wireless organization. Now, if you look at, oops, this is a pointer thing. There you go, right? So in 2010, if you were using data, there was 1 dot, right? In 2018, that grew up to 40 dots. Everybody is eating, drinking, breathing, living, sleeping data, right? That's how it's growing. And one of the recent statistics says it's not even 40 times anymore, it's growing 63 times from 2014 to 2023. So everybody is eating data. Now, how is this data being fed to you? And in terms of data statistics, you got 15 trillion megabytes, right? You got to multiply by 10 to the 12 and then another 10 to the 6. So it keeps going. And that's equivalent to streaming every single episode of Game of Thrones to 249 million users. Right? That's the amount of data that was consumed in 1 year, and that was in 2017. So the data is exploding in terms of what people want to consume in terms of content. Right? So how do you deliver all this data, right? There's, people, we used to have wired networks, we went to wireless networks, there's Wi-Fi, but there's not enough wireless channels available out there to scale with the data that is needed for everybody, right? Everybody wants 4K videos on their phones. I know most of you think, but there are people, millennials out there, there's people in the stadiums, they all want 4K data on their phones, and you'll see some use cases that I'll show that makes all this necessary. At the same time, spectrum, and you don't want to be tethered to your computer or anything. Everybody wants it on their phone. It has to be on a wireless channel. So spectrum is very scarce, and you can see all these things about how people are auctioning off spectrum, they're buying spectrum, and capacity is a big problem, right? And when you go to, they're building a new Warrior Stadium. EC site is a part of that process. And I've been to the, probably one of the first few Desi guys who went into that stadium while it's still being built. Huge stadium, and apparently the suite there is about $2 million a year, right? And they have about 20,000 seats. They want to send so much data that every seat or every other seat is going to have an antenna radiating, right? How does it affect your bottom? That's a different story. But every seat is going to have an antenna, right? Because they want to be able to live stream the game to the audience. And let's say you missed a Steph Curry dunk. You want to rewind right there and see it at 4K. Right, and they want to be able to provide that, and so every other seat is going to have an antenna. So when you buy your season tickets or buy your ticket, season tickets are not available anymore. But when you buy your tickets, let me know. I'll tell you which seat has an antenna, so that you can pick the other seat, so that you can sit on it. Okay, so there's just huge data needed, and how do you solve that is by going to newer technologies, right? More efficient technologies, and spectrum in that we know today is done, right? There's no more airways available for anybody to sell, right? So you have to go to what is called 5G, right? And then they're calling that 5G. You'll see what is called 5G NR, which means 5G new radio, right? And these, I put all these statistics up because it's just mind-boggling, right? 400 million mobile devices, it's all US. Each one of you have one phone, you think, but because so many people have more than one phone, there's about 1.2 devices per person. Right, so the smartphones are there. The data is being shoved down your throat. So you need to come up with new technologies, and that's where 5G comes in. And 5G, so today we have somewhere between 5 to 10 megahertz of bandwidth per carrier, okay? So 5G is going to have 100 megahertz of bandwidth, 100 megahertz of bandwidth per carrier, right? And so you see this huge growth, and most applications for 5G is determined by having to have very low latency, right? And that's very important for streaming, right? You're watching Aintusan, things just stop and buffer, right, on your wireless network. But anyway, I'm just being funny about it. But latency is very important, and they're trying to guarantee. Today's latency is somewhere between. Actually, this might be 4 milliseconds, but today's latency is somewhere about 10 milliseconds, right? And that could be a problem in some applications, right? And you'll also see this related to 5G. You'll see what is called a CBRS, Citizens Band Radio, at 3.5 gigahertz. There is LTE private networks called LAA, licensed LTE assisted. Something for the A as well. So it's 5 in the Wi-Fi band, and then there's this thing called Wi-Fi 6. Really, what happened with Wi-Fi is that they ran out of acronyms, right? You got A, B, G, and then they went to A, B, A, C, and now they went up to AX. So now they reset and they called it Wi-Fi 6. Again, this is a huge bandwidth again, right? So again, they'll aggregate all kinds of channels. So for example, some of the things that they're doing is that they'll aggregate a 700 megahertz channel with a 3.5 gigahertz channel to give you more bandwidth. Right? Because again, downlink and uplink is very important, right? And how are they going to achieve all of this, right? You already have cell towers up every single house or and then, so now they're deploying a lot of in-building systems, right? Today, I mean, I came here, I want to look at my slides, the cell phone doesn't work here, right? And that's a problem, and I don't want to connect to the Wi-Fi networks because you don't know who's going to steal your data or whatever. So you trust the carriers more, so a lot of them are deploying in-building systems. Okay, and you'll also see just about every lamppost. If you go to the city of San Francisco and the city of San Jose, in downtown, every single lamppost will have an antenna, and they're trying to do 4G and 5G small cells, right? So that's how they're going to try and serve you up with all the capacity that you need. And 5G is, you can't see it really here because clearly because the screen is bent. Most of real 5G comes in the 24 gigahertz band. So today we're all in the microwave kind of bands, which 1 gigahertz, and really microwave is microwave, right? So in essence, we're all sitting inside an oven 24/7, right? In a microwave oven, but pretty low radiation levels. But this millimeter wave is high bands, right? And it's called millimeter wave, 28 gigahertz and above, and that's where they're going to be deploying most of this 4K 5G, right? And we're living in a generation where let's say in the last 20 years we've all been here. We used to have, not too long ago, 28K modems, right? We've gone from 28K modems to 5G today is 2 gigabits downlink, 2 gigabits. Unbelievable. It's 6 orders of magnitude in a 20-year time frame. That's how much technology has grown, and you've all driven the demand for it, right? All right, and then I'm going to conclude here with some applications you might think what you need it for. Somebody alluded to Industry 4.0. So there's a lot of AR applications, real applications. It's not just fun and gaming applications. A lot of AR applications. You got, like I said, the 4K video to every user, and immersive experiences for different kinds of use cases. And you'll see a lot of work in automotive, right? And then there's a factory of the future. You'll see a lot of vehicle-to-vehicle communications. That's going to happen sometime soon here, where all the vehicles will be talking to each other and saying, "Hey, I'm right next to you. Please don't rear-end me," right? So autonomous driving will be real. So precision agriculture, a lot of things happening here, and the opportunities are enormous, right? So when you want to think of new things that you want to do, one of the purposes of you being here, think of not what problem you're solving today, what problem do you want to solve 10 years from now, right? And that's where the real use cases would be. All right, with that I'll conclude, and the next speaker would be Anand, talk about Yugabyte and how to manage and get all this data into the system.
Yeah, hi folks. So again, I'm going to give you a little bit of an overview of Yugabyte. At the core, Yugabyte is the company behind Yugabyte DB. We are building a database in the open source. It's a highly scalable, distributed database with SQL, the SQL query language, as its interface. And before I get into more details, I just wanted to share a few trends that we're commonly seeing in enterprise applications, right? And just to orient folks, the kind of applications that we're talking about are not so much, at least in the context of Yugabyte, it's not so much in the analytics space, but more customer-facing, real-time transactional applications. Think of what goes behind an Uber app. How do you find and match the drivers? How do you know where your current car is? Or a payment processing system, or a retailer like eBay, or a messaging platform like WhatsApp. Think of the systems that are behind the scenes and the kind of databases, the low latency, highly scalable databases that are required to power these apps. So essentially in that dimension, the secular trends that are happening are enterprises are moving to a cloud native architecture. And by that, we don't just mean that they're moving to running services in AWS or Amazon Cloud or Google Cloud, but fundamentally it's a paradigm. Companies are moving towards infrastructure that is highly elastic, be it in the private cloud or in public cloud. Hardware that you start small and you scale as you go and so on and so forth. We are out of the mainframe kind of computing world where you buy big beefy servers up front, right? So that is real, and the key factors that are driving that transition are the need to have a very fast time to market on your products, right? Fast development, ease of operations, and really the luxury of having on-demand elasticity. You don't upfront want to commit to a huge infrastructure budget. The second thing we are seeing is that enterprises want to really adopt a multi-cloud or a hybrid cloud strategy. They want to minimize the dependence or lock-in of building infrastructure that cannot come out later from AWS or Google Cloud, and really make it, keep the options open, de-risk the future. If they want to come back to private cloud after the fact, or go to a different cloud provider, all of those options need to be available. So that's another trend that we're seeing. And last but not the least, it's not just the web scale companies like Uber and Facebook that are seeing this data problem. Even a startup, a 30 to 40% startup, the real distinction, competitive advantage it can bring to customers is by being able to crunch and serve data. Data is ultimately at the heart of powering a competitive business. And so we're seeing this rapid growth in transactional data. You could say the first wave of this happened in the analytics space, but like real-time transactional applications are growing really rapidly at even small to mid-sized companies. And the key challenge in enterprises embracing this cloud native, this elastic infrastructure is at the data or the database tier. Thanks to virtualization, that VMware brought forward back in the day, containerization, the application tier has become pretty elastic, but the database tier remains a massive challenge. And traditional databases like Oracle, MySQL, they're transactional, they're very feature rich, but they're not very elastic. They can't grow to hundreds or thousands of nodes to serve apps like Uber or Slack or WhatsApp, right? So you need a different kind of data infrastructure. And there have been like a first generation of elastic databases.
This is actually not just an observation. This is like a study from McKinsey, which don't worry too much about the details. It broadly paints the picture paints the picture of the potential of AI and automation in transforming the business as we know today. And the thing that I like about this study is that it keeps aside all the hype and the buzz about AI and really focuses on what would be the nature of that kind of a transformation that will come about, which is it's going to be part of two important aspects. One is AI will play a significant role, but in the broader picture of analytics, which is important to all businesses. Like as we talk about data-driven decisions are going to be at the heart of all successful businesses, and analytics is going to play that role, and AI is going to make a difference in that. And it quantifies what would be that percentage of impact that AI could have in the broader analytics. The other thing is, when we talk about work, we cannot talk about like the value that ML can bring without talking about automation. Automation is going to be the key kind of vehicle through which many of these, if you want, efficiency or productivity growth is going to come from. And this one actually talks about that. So, so I want to just focus on one, which is economic potential of AI is going to come from productivity increase. As we look at like GDP growth of any country, productivity growth really improves like economic growth. From that perspective, there are two aspects that we are going to see. One is transformed workspaces, and actually it's not we are going to see, we are already seeing in many places that this is true. You can walk into the Tesla factory here, right here, and see many of it. And also transformed workflows. That's the part that is emerging, and we are going to see more and more of it. With that, I'll just do a quick plug for something that is related to the company that I'm working, Workday. What we are focusing on, the area that we are focusing on applying machine learning is on transforming these workflows. So Workday is an enterprise SaaS company, and it builds products for human resource management, financial management, and planning and analytics. So as you can think, any big enterprises goes through this loop, right? You plan something, you execute that plan, and then you come back and analyze, collect data, and you analyze, and you plan again, and you keep doing. So you can think of these tools actually facilitating that. So now if you think about one of the transformations that AI is going to make to help enterprises be better and get that productivity benefit, it's around those workflows. So that's kind of what we are focusing on in terms of looking at workflows across all these various aspects and how we can apply machine learning to actually make them more productive, make them more personalized. And one thing that differentiates is in terms of focusing on delivering true value instead of, it's quite often you might see a machine learning product that you look at and say, huh, that's interesting, and you just walk away. It didn't really deliver any true value to you as for your business. So it's hard to tease out cases where you can deliver true value, but they do exist. And going after them, we find it is much more worth. And this is my last slide. One thing, what I want to close is, it's more my opinion, not Workday. So future of work is going to be machines assisting humans and not machines replacing humans. I really believe machines assisting humans in enabling them to do the more mundane routine tasks or tasks that are physically very demanding. So they take away and do those jobs, and the humans actually perform the more, like managing the machines if you want. And with the caveat that you need to embrace this technology, embrace this with a lot of careful thought on things like bias and fairness and doing this in an ethical way. I think Subbu has some questions on that. We can come back to it later. So that I'll close, and thank you.
Okay, these guys all talk about technology. Last time I did technology was 20 years ago, so I'm gonna talk about the business problem that Lumity solves. Lumity is in the healthcare and health insurance business. So if you look at the US health and health insurance market, it's not measured in billions, which is typical of many industries around here. It's measured in trillions. And there's a lot of inefficiency and waste in the health insurance and health space. What we are doing is we're using data science to solve a problem for mid-sized companies. Mid-sized companies, we define it as anything between 50, 60 to about 1,000 employees. So if you look at what's going on in the space, most of these companies have no idea what their employees' true health needs are. They cannot know that, because there are laws like ERISA and HIPAA which prohibit the employers from knowing the health status of their employees because of the fear of discrimination. So if you know somebody's got some disease, diabetes, maybe you're not going to give them a big raise and you're going to drive them out of the company. So The government has laid down these rules and laws, so you as an employee cannot know the health status of your employees. But then if you look at the HR department of these companies, they are making choices around what kind of benefits they're offering to their employees, what kind of plans they're picking. Do we pick a PPO plan with this level of deductible or that level of deductible? What kind of coverages it offers, right? And the employees get these plans, they make these choices blindly. As a result, you have a lot of inefficiency. For example, a 20-year-old picks a PPO plan and never sees a doctor. So it costs the company about $11,000 to insure them over the year, and this 20-year-old gets about $3,000 or $4,000 deducted from their paycheck over the year. So it results in a lot of waste. Another problem with this is that when every year you guys go through open enrollment and select plans, the employers go to the insurance company and negotiate the rate for the next year. The employers don't know how many people with cancer are in their employee population. They don't know anything about what's going on with their employees. But the insurance company has perfect data on your employees because they're the ones who are processing the claims, they're the ones who are paying the claims when you go see a doctor, so they know exactly what your medical conditions are, how much it's going to cost them next year, right? And how risky your group is. So the employer is going to the table to negotiate with the insurer where they have zero advantage. If the insurer says, I'm going to give you a 20% raise because you're bad risk, they have nothing to push back with because they're not supposed to know what the employee's health status is. So what we've done is we've built a platform that enables employees to come and give us their health data. And it's not an invasive process. You don't have to fill out any survey. You just click a checkbox and give us authorization. In real time, we go aggregate data. I can get into the details of what that data is. About 7 years of your health history, and if you have dependents, 7 years of their health history as well. And we built a big data model based on medical claims history from 70 million American lives for the past 15 years. It's sort of like a predictive model. I can't get into the details. I mean, I can roll in my architect and data scientist if you guys want to know how that works. But what that data model does is takes the data for you and your family and predicts what your needs are going to be for the coming plan year. And if you're in a company that offers you 4 or 5 plans, it tells you under what plan are you going to get the most coverage for the least amount of cost, right? Then we aggregate and anonymize that data at a company level and use that to negotiate with the insurance carrier. So as a result, we're able to save somewhere between 10 to 15% on the health benefits cost for typical employers that we go engage with. So some of our big customers, I mean, I don't know if you guys can see the logos, it's pretty washed out. Lyft, Robinhood, Bird, thousands of employees. For them, for a company like Lyft, a 10% savings in a given year is about $3 to $4 million, right? And that savings is being delivered pretty much for the same coverage at no additional cost to the employer. So that's basically what we do. If you go down to the next slide. I am the one who, okay. So that's kind of what we do. Like, and I think I described it, sorry, I didn't flip the slide. So that's our process to optimize health benefits for large, like medium-sized employers. If any of you who are entrepreneurs think you're paying a lot of money for benefits and not getting enough value, talk to me afterwards. Benefits is the second largest cost after salaries in all employees' books. So we deliver on a reliable basis about 10 to 15%, improve your workflows, improve the experience for your employees, and do all of that at no additional cost to the employers that we engage with.
We have some customers in the audience too, right?
Hello, everybody.
Do you want to put the slides up? Or?
No, that's okay. No worries. So I asked him if I needed slides, but he said my good looks are enough. So that's his word for it. Visru is a zero-code platform for delivering what's called autonomous applications. And we talked about automation. We actually wanted to go to the next wave. We call it autonomy, autonomous applications. These are applications that can act and think on their own. An example of that is BNP Paribas. BNP Paribas being one of the largest bank and an insurance company in the world. And we first launched the end-to-end claims automation for BNP Paribas. So just to give you an example, each claim, before we signed the partnership with BNP, each claim used to take 8 weeks, has to go through about 220 individual steps from OCR, detecting if there is drug-related stuff as part of the accident, police report, medical report, and all that stuff. So there are 220 distinct steps that it had to go through. So it took them about 8 weeks. So it took us about 3 months to deploy in Spain, end-to-end, this autonomous application. And now they can actually intake the claim all the way to approval of the claim in less than 45 seconds. So an 8-week process, our autonomous application actually approves the claim in less than 45 seconds. And there is a compelling need for that because there is Lemonade, there is Metromile, there are so many different new insurance providers in the market where they are eating the incumbents for lunch. So they wanted to actually build something so quick, so rapid. So the answer to this is absolutely, it has to be a zero-code platform because it should allow them to constantly evolve. We talked about so many different versions of AI. AI is at absolutely an infant stage. It is like 10 blind men looking at an elephant. It is going to constantly be changing. So if we end up building something for 18 months and just the next day it's going to change. So what we delivered is a zero-code platform. And there is 2 IP to the platform. One is called as a cognitive UI. And cognitive UI is naturally, it's allowing customers to communicate with the platform on the channel of their choice. Voice, we even receive information from voice to text, from chat naturally, from any other traditional channels that's out there. That's the cognitive UI. The second aspect is called as a snap layer that is called the stateful network for AI processes. So it's essentially a guardrail that we've actually built where these bots can actually communicate with each other. And these two are our intellectual property that is allowing us to deploy, not a POC, what we call as a minimum viable product in less than 4 weeks. And we've been able to consistently do this within the insurance company for claims automation, underwriting automation, policy management. So that's what we do, and I'll be happy to field any questions after the questions.
Thanks, Ramesh. All right, so thank you all. That was very enlightening. I learned quite a few things, and hopefully all of you can take away. And I think all of you guys are hiring, right? So after this, please, if there are things and opportunities for you to talk through, then you're welcome to do that as well. Yeah. So let's say I'll start off with a question, right? And maybe 5-6 years ago, when data was actually big data, people used to say data is the next oil, right? But now it feels like we're on a slippery slope, right, from that oil, because it's just I don't know who has my data, who doesn't have my data, what they do with the data. So all of that becomes a problem, and there are enablers who are enabling this huge data collection. Now, what I want to hear from the panel is, where do you guys, where are we in the data landscape? Is this data 2.0, 3.0, and how does this security, the privacy issues, and then we'll get into about the ethics of AI and stuff like that. But where is that? Where do you guys see data evolving and taking us to in this landscape? And I'll start off with Kannan.
Thanks, Subbu. Great question. I don't know about the version we are in with data. Maybe it is 3.0. But one of the things that in this role really enjoyed is talking to lots of customers, architecting solutions that have to make these decisions day in and day out. And a couple of common themes that are emerging. One is GDPR is on a lot of people's minds. Data of certain users living in certain countries cannot leave those boundaries. It's okay to be in transit, but at rest it must be in their geographies. Right? That puts a lot of onus on enterprises to architect systems where they can do some kind of geo-partitioning of data based on the user, the account, and so on. And that's a massive challenge. In some situations, it's fine. You just create separate deployments of your full stack for each geography. But then there are companies that actually, single companies, having customer base across the world. It's a massive problem. So I think a lot of the systems that can help solve these problems will really shine in the coming years. And maybe a second aspect that comes up a lot is anonymization and just forgetting about the data. You took somebody's credit card number and you have a lot of records in your system with that, but if the customer calls you and says, I want you to delete my account, that's a hard problem all the way, in all your analytics systems and your transactional systems. So people are spending a lot of engineering effort to solve these problems, and they are really opportunities for entrepreneurs to be thinking about.
It's a great point. I'll share the perspective from the enterprise data sets kind of experience that I have had, which echoes some of the things that you brought up. Really, it is a new view of data that is emerging, both in the consumer space and enterprise space. The enterprise space has a little bit of advantage, I would say, which is really rare, right? Normally it trails the consumer space when it comes to technology. Here, the perspective I want to share is the reason that enterprise space has an advantage when it comes to things like GDPR, or California has its own, right, CCPA kind of regulations about privacy of your data. So I'll give a one-minute summary of that. We all want to know what data about us is being collected. We all want to know what it is being used for. So that is transparency. We want that. Any product we use, we want to know, be it enterprise, be it this thing. The second aspect that we all want to know, we all want is control over it. When I want to actually, a company or a product not use it, I want to be able to actually click a button and completely erase it, like the right to be forgotten kind of thing that you mentioned. This is also true. And the last aspect is, if a company wants to use our data, a company or product, for a different purpose than what we are told, we want them to explicitly come and get our permission. We just take these three. These three typically, now if you compare it to the end user license agreement, we click and sign off for any Google, Facebook, or any other product, you can go and read it. None of them gives you this transparency or control, for example. When you say, I don't agree, you don't get to use the product. That's all. That's pretty much what it is. You don't get a specialized version that doesn't use your data. But enterprises has traditionally been engineered to actually take into account some of this privacy and other concerns. Not so much when it comes to building analytics and machine learning. So that's the problem that many enterprises are solving. But based on that, enterprises have actually historically had a higher bar when it comes to, for example, storing and processing credit card data, right? There is a lot of laws, like a lot of audits and stuff like that there. So at this point, enterprises have a little bit of advantage in, for example, implementing GDPR, when compared to like Google or Facebook trying to actually implement it across the board for all customers. So I would say data is in a very interesting state. And the notion of privacy, the awareness around privacy is increasing every day. Very likely, similar to GDPR, we would have another regulation in US that's going to come sweeping across, and that would have a huge impact on all products trying to figure out how to actually implement this, and that's a huge opportunity. That's really a huge opportunity. Even the simplest thing, like similar to SOC audit, today we don't have a GDPR audit that a company can offer, that companies can just buy, show their systems, get like approved and say like, hey, we are GDPR compliant. Starting from there, across the board, there is tremendous amount of
that are put in place. People who have diabetes, now they have glucose monitors. that actually hook up with the cloud and report the data back to the insurer. Because the insurer really wants to make sure that you're taking the medication and you're not going to become a liability a week later, ending up in urgent care or emergency, costing them thousands of dollars because you didn't take your medication on time. So it's definitely 2.0 in healthcare space. What's more interesting is how open and trusting people are in sharing their healthcare data, right? You look at our model, it completely depends on employees willing to give us their health information. So we can analyze it and give them some value, which is, this is the best plan for you. Here's where you're gonna spend the least amount of money, which is value for them. And also, if we, on overall basis, if we bring the healthcare cost down for the employee benefits also, because these days, because of healthcare inflation, employees are bearing about 40% of the cost of their healthcare, right? So it helps them. But when we went to raise seed money, the first question they asked us was, nobody's going to give you their health information, and you're going to fail because of that. But then, somebody trusted us and gave us $3 million to go prove that that is not the case.
Did they give you their health data?
Yeah. So right now on our platform, about 90% of employees who go through and select plans on our platform trust us with their health information. And that's not just like, I sneezed here, I sneezed there. 7 years of what medication you took, which doctor you went to, which pharmacy you went and picked up your prescriptions from. All of the data is being sucked in by us in less than 10 seconds across a network of providers, right? So people are way more trusting if you give them some value back.
Yeah.
People are trusting.
But is that a good thing? Is that a good thing to trust all these companies with our data?
We go through the employer, right? The employer is doing diligence on us to make sure that our infrastructure is safe, our security measures are good. For example, Robinhood, which is a financial services company, is putting us through the rigor. We don't do our own pen tests. Pen tests are being done by the customers. So if they break us at any point in time, we have to remedy it right away, right? So employers are testing us and making sure that we are secure to be able to trust their employees' health data with us. And of course, there's forget me features there. If an employee wants to leave the system and want us to delete the data, we'll delete it right away.
So you have that full stack deletion, like Kanan was saying,
Yeah,
was
of course.
very hard to do. And,
Yeah, it is hard. In our case, the entire algorithm that does the prediction is running in a HIPAA-compliant AWS cloud, right? It's a separate instance. It's sort of like a microservice. Data, nobody, including me, has access to the employee's health data. It just directly goes in there, gets encrypted. It does the analysis. All we see is a risk score or a recommendation that comes out of it. So we have the ability to go delete just that part very easily without having to worry about anything else. So people are becoming more open, and as a result, a lot of data that wasn't accessible to healthcare providers is being made accessible. And people are more trusting and are willing to share information that makes services like us possible.
Okay.
Yes, to answer your question, I think the first version we got too excited. Naturally, US tends to do that. It exploits itself way too much, the first version. And to Europe's credit, to be honest, they have become much more progressive, much more advanced in consumer protection in the form of GDPR. And I have a lot of first-hand experience because one of the first customer we went after is a European customer, so BNP Paribas, and they actually sent about a team of folks over here. The data protection, only then I realized there are certain interesting nuances to it. One of the important questions they asked was, when the data gets stored, if the data gets stored at rest in your country, especially in the United States, can NSA subpoena that data? That would mean that there is a mandate that I have to submit. So there are so many different layers and nuances that we did not think about when we actually started exploiting our own data. It is extraordinary. It's somebody, if they want to take my name, I go and search in Google, and if it says Ramesh Mahalingam is living somewhere else, it can completely ruin our life. And the problem with data is that we have taken ourselves so much for granted. By selling ourselves, we basically said, I will take his data, and I'll sell his data, and he said, he's going to take my data, and he's going to sell my data. So, so we were on slippery slope, of course. If we let just US run it, to be honest, that's what would have happened. But thanks to Europe, by bringing such tremendous consumer protection to a point that Microsoft actually moved away from Germany, and actually we got in because of that, thankfully, but Microsoft and IBM could not remove this type of data out of transaction. So there was such consumer protection that Europe actually brought. Now California is actually is catching up to it. FINRA compliance is actually catching up to it. So thanks to Europe, to be honest, that's where it is. But the biggest challenge right now is India. India has to start protecting itself by not just opening Google to just everywhere in all railway stations.
Right?
Everywhere in railway stations, you go hug Sundar Pichai and get all the Wi-Fi. That's going to be a problem for India. We have to be very cautious going forward, I think.
Yeah, thank you for that. I think we're very short on time. Maybe we'll have the questions.
We'll have an audience question, yeah.
Audience questions, okay.
Yeah.
All right.
Could you just give them a microphone?
Yeah, you can have it.
It's so relevant that we are talking about data today. You must have seen the news regarding Hughes met with Facebook guy and he's asking Facebook to split basically. We're going back to the AT&T baby bell days. What is your take on that?
Anybody wants to take that question?
Yeah, I think it is a very relevant question. I think exactly like an antitrust, data can make or break. I think now it is at a point where all these companies that are actually exploiting, either Google and Facebook and Amazon, to be honest, we really thought we can actually start using data as the product, and everybody's data as a product. So that era is actually coming to an end, and this is high time that we as consumers are aware of this and demand, and certainly I think it is the right thing to happen today. It will happen.
Yeah, I was just going to say, don't know the exact details of the news. Don't know the exact details of the news, whether splitting makes sense or not, but would agree with one of the panelists who said that the companies have to be very transparent about what they're collecting, what they're sharing with, and be responsible and accountable if they violate the trust.
I mean, would you all agree that when you build a company now, you have to really think of what your data architecture is, right? And how it's being split, how it's being stored, how it's being served, right?
That could be a differentiator for you.
This will actually tantamount to, because Google and Apple are sitting on the sidelines.
That's right.
And they're just watching it, and they're saying, let there be an oversight, because they'll be the next target. Okay?
That's right.
So we'll be basically splitting Google,
That's right.
Apple, everybody.
Right, yeah.
Do not know.
Do not know, yeah.
That's the way to go.
Yeah.
So the data has been cross-pollinated with all the data brokers. There's lots of them out there. So the question is, will data anonymization really work? Okay, I'd like to get your thoughts on it.
I can give a technical answer. Probably others have a more business perspective to it. Technically, pretty much even the sophisticated techniques are not good enough to completely anonymize, because given the amount of information accessible to us, it's only a few hops away. Like it could be anonymized based on maybe somebody just turned it into a secret or into a hash or something. But once you have a side information, like you can go and Google about either a hash or other information, you can easily link. So that is really a hard one. The approach would be is to protect it at the first place and do aggregation and use only aggregated kind of results. That is it.
So yes, could you say?
More questions.
I want a lady to ask this.
Excellent panel, fantastic quality. Thank you all very much. I wanted to understand a little bit, I know the focus is all about data, but I wanted to understand a little bit about your early journey. I think it will be extremely useful for everybody in the audience, including you.
Well, I think we're running out of time though, because if we all, our stories are very difficult stories. So if we start from there, so we will talk definitely another time. That's okay with you.
I have a specific one for you.
Okay, all right, please, yeah.
I think digressing from the data topic, when it comes to 5G, I've been part of the network and telecom industry for many years. So there's this notion that network disaggregation, where you build nodes on open source technologies. You see Facebook tip and a bunch of non-operators trying to advance the technology so that even remote areas get connectivity. It's coming up. What are your views? Is there a financial, commercial model to it? It will continue to be open source. Just get your thoughts on that.
Yeah. So the telecom industry is a dinosaur, right? And unfortunately, they're surviving dinosaurs in the sense as we have the Ericssons, Nokias. It's very hard to penetrate that. Particularly, would you trust an open source? I mean, no offense to open source movement people here. Would you trust an open source to carry all this protection that they have and go into the core network and eventually make the calls, right? And again, there's the privacy questions also come into place. So there's a lot of things like that out there. But I'm all for let's say more and more operators. Like if you see the CBRS band that I talked about, the LAA, you can actually become an operator. Let's say I can deploy a CBRS network here in this office, and I can become an operator, and I can lease this back to AT&T if I want to. So that is coming, right? But who provides the network for that, and whether you can use open source infrastructure for that, that is all, the jury is still out. But I mean, I like the way the industry is going towards all of this, to both self-organizing networks on the wireless side, and also core networks becoming more open source. Right, so. All right, so one more question, or Prakash, over here?
Okay, one more. All right. Sorry.
Is the fear of Huawei being a menacing threat in the 5G area, is it unfounded, or is it based on some fact?
Well, I guess we're all, let's say, to use a right word, suckers for cheap and free, right? I mean, because we're all here because Google was free, and the data exploded, and now we have a problem, right? Now, Huawei, I mean, as a technology company, they're a fantastic company, right? And Chinese-based, and obviously, once we have the patent rights being properly solved, right, that they would, I remember the reason why Huawei, because in the telecom industry, the Huawei, the big routers and all that they had on the core network came up with the Cisco logo. Yeah. All right, and that's how bad it was. Yes. And certainly they evolved from there, but their footing, what they started out with, was not right. And so there's always, and even today, I mean, I was really surprised. We did some work for NASA at NextNav. NASA is flying drones, and if people are in the drone space, DJI is the most popular drone. Guess who makes it? It's DJI in Taiwan. And guess what it's doing? When they fly the drones in NASA, the drones are sending data back to Taiwan in NASA, right? And so the government then issued a mandate saying no more DJI drones, no more US non-US companies. And even today, the US manufacturers are not able to put up a good drone out there that competes at the price level and the integration level that DJI has. So what NASA does is now buys the frames from DJI, because those are the frames that are the best out there, and puts their own hardware and software on it, but it's still not there yet. So similarly, on the Huawei side, I think they have great phones, they have great technology, and they'll catch up with whatever we're doing, right? Whatever Qualcomm does, there will be a replica of that in 1 year, 5 months, 6 months. They will definitely catch up with that. So it's a question of whether the US will allow some of these IP violations and stuff like that and get them into the market.